Hi, I'm Mike Yawn, a Senior Solutions Architect with Hazelcast, and this is Television. In this episode, we look at why calling your Hazelcast setup a cluster isn't a bad thing, and how a clustered architecture is at the foundation of Hazelcast's design. Many of the benefits that Hazelcast provides derive directly from its clustered design. By clustering nodes together, we can use the pooled resources of all the nodes in the cluster, including CPU, memory, and network bandwidth, giving us capacity that exceeds what we might get with our individual servers. We can also continue to operate normally even when we have a node failure due to features such as in-memory backups and partition migration. These are topics we'll cover in upcoming episodes. Distributed operations can happen concurrently on multiple nodes. Developers don't need to write a distributed algorithm that's aware of the distributed nature of the data store. That's all handled transparently. And we don't have to know our growth demands up front and size for maximum workload. Instead, we can start with the capacity we need now and elastically scale up by adding additional nodes without downtime. If we have spikes in demand, such as a retailer during holiday periods, we can scale back down in the same way when we no longer need that capacity. All of this comes from the clustered architecture of Hazelcast, so let's see what that means. With some products, the default mode of operation is standalone, and if you need more storage than will fit on a single node, then you add a separate clustering module or product. But when you start a Hazelcast node, you have created a cluster. It doesn't think, I'm running as a standalone single node deployment. It thinks, I'm the first one here. I'll just handle the workload myself until somebody else comes along to pitch in. Hazelcast cluster membership is dynamic. Clusters can elastically scale in or out without downtime. A cluster is always open to connection requests from newly started or recovering members. Maybe a cluster member had a rough night and he's a little late coming to work in the morning. The discovery mechanism used by cluster members to find each other is configurable. By default, they use multicast and will look for members on the same subnet. If you configure TCP/IP discovery, then we'll look for members with specifically configured IP addresses. If you deploy on Kubernetes, we'll use the Kubernetes discovery mechanism, which may involve sacrificing a goat or something. There are also discovery plugins for the various cloud service providers, so we can work in environments that don't have fixed IP addresses, for example. Cluster connections are mostly peer-to-peer. There isn't a primary replica or leader-follower relationship for the most part. There are a few exceptions to this. We mentioned up front that an advantage of clustering is that we can pool the resources of our cluster members to give us greater scale. But in order to get from more to better, we have to have intelligent access to that distributed data. One way we do this is by smart clients. When data is distributed across the members, it is done so by a hashing algorithm which helps identify which member hosts the data for whatever piece of data we want. This distribution strategy is known to both members and clients. As a result, clients can make data requests directly to the member hosting the data, avoiding extra network hops, and helping spread data access requests evenly across the cluster. When data is distributed across members, it is further divided into a number of partitions. We'll talk a lot about partitions in our next episode. For now, let's just note that we can operate on partitions in parallel due to Hazelcast's threading model. Operation times can be dramatically reduced due to this parallel processing across nodes and partitions. This is a key differentiator, making Hazelcast's fast data store highly performant when contrasted with simple caching solutions. You know who you are. Let's recap. Clustering is an integral part of the Hazelcast architecture. Clustering benefits include capacity, resiliency, performance, and elastic scaling. Cluster membership can change dynamically while the cluster continues to run. This might be due to planned or unplanned reasons. Clusters can use different discovery mechanisms. You can choose the one most appropriate to your deployment environment. Smart clients help performance of your cluster by routing requests directly to the appropriate member. Data is not only distributed across nodes, but also across partitions on each node. And we'll get into that in the next episode. So that's where we'll leave things for today. Thanks for tuning in, and we'll see you next time.